Alright guys, here's our video on the electromagnetic spectrum. If you have not checked out the video on light properties, you should do that first and then come back and check this video out. So when we talk about the electromagnetic spectrum, we're talking about the entire range of electromagnetic waves from the lowest frequency with the longest wavelength and the least energy up to waves that have really high frequencies with very short wavelengths and lots of energy. Remember that there's a direct relationship between frequency and energy, and there's an inverse relationship between frequency and wavelength. That also means that there's an inverse relationship between wavelength and energy. So you should be kind of aware of those relationships. So when we talk about the electromagnetic spectrum, our first type of wave, this is a wave like all the way down here on the electromagnetic spectrum, are called radio waves. These have the least energy, the longest wavelength, the lowest frequencies. These are types of waves that are used to transmit radio, like AM and FM radio. There's a fairly wide range of frequencies that are available. These are also the type of waves that are typically used for your cell phones or your like Wi-Fi in your house. So when you tune into a radio station, FM radio station, that station number, like 107.7, that is just the frequency of the wave that information is being carried on. So it's kind of interesting, and we use these a lot that are being broadcast all over the place. Microwaves are our next type of wave. These have some shorter wavelengths and higher frequencies than that of the radio waves. These are the type of wave that's used in a microwave oven. And these waves are absorbed really, really well by water. And that's how a microwave oven works, is a microwave oven will emit microwaves into the food. The water in that food absorbs that energy and begins to heat up, converts that radiant energy into thermal energy. That thermal energy then is used to cook the food, so it's the water that actually ends up cooking the food. But these waves are also used in what's called radar. So radar is a way of like tracking materials or objects. So radio waves are sent out from a tower. They will bounce off objects and come back. And how long it takes for these waves to return tells us about how far away the object is. And as that time it takes the waves to return back to the broadcast tower, as that time increases, it means that the object is getting further away. Or if that time decreases, it means the object is getting closer to the tower. We can also tell how big or what shape an object has based on the amount of waves that come back and the shape of the waves as they come back to us. So these microwaves, besides being used to cook food, which is an amazing invention, they're also being used in radar to track objects. Our next type of wave is infrared waves. Now when you get into this batch of the electromagnetic spectrum, we start to get waves where we get a lot of them from the sun. Infrared, that prefix infra means below. So these are waves that have a frequency below that of the color red. These are waves that we can't see, but we do feel them. We feel them as heat. And sometimes you'll see in the food service industry, you'll see these like trays with food on them, and then there's light bulbs above them, but these light bulbs emit a lot of infrared waves to keep the food warm. So these are like warming lights or heat lamps. We get a lot of these waves though from the sun, and that's when you're standing out in the sun and you feel the heat. What you're feeling is the infrared waves. Next, we get into our visible light spectrum. Our visible light spectrum is a series of waves that we are able to see with our eyes. We see them as colors. It's a really narrow band that we can see of these electromagnetic waves, but they're arranged from the lowest frequency, longest wavelength, and least energy in red, all the way to the highest energy, highest frequency, and shortest wavelength in the color violet. So you probably know the order of these colors as Roy G. Biv, or red, orange, yellow, green, blue, indigo, and violet. And you should make sure that you do know the order of the colors from the lowest energy to the highest energy. That's going to be important for us this year. More energy than the light that we can see is a series of waves called ultraviolet. That prefix ultra means above, so these are waves with a frequency above that of the color violet. These are also, we get a lot of these produced by the sun, and these can be both beneficial to us and they can be hazardous to us. Hazardous, they can cause sunburn and skin cancer and things like that. But they also, when these waves react with your skin, they also produce vitamin D, which is important for our health. Some people actually have ultraviolet lights in their house so that in winter, where we're getting less direct sunlight and we're getting less ultraviolet light reaching the surface where we are, they can get enough vitamin D from lights in their house. But again, too much is a bad thing. So it has the ability to cause skin cancer, things like that, because these waves have a lot of energy and they can cause damage to your cells. Being able to cause damage to cells is also, however, another benefit to us. And ultraviolet lights can be used to kill bacteria and viruses. In fact, the goggle cabinets where we load up all the goggles after we're done doing labs, that has ultraviolet lights inside. So when I turn it on, it runs ultraviolet light and helps to sterilize, kill bacteria and viruses that could be on those goggles, so that the person after you that uses them isn't getting potentially any bacteria or viruses if you happen to be sick, even if you're unaware that you're sick. We're not transmitting that around. They're also used in the medical industry for the same purpose. And doctors can use ultraviolet light to sterilize their tools and without having to use chemicals on them. Now, our next wave, these are called X-rays, and now we're really getting into waves that have a lot of energy. X-rays have so much energy that these waves pass right through your soft tissues, like through your skin, through your muscle, through your ligaments and tendons. But they don't have enough energy to pass through your bone. Instead, they reflect off of it. And this allows doctors to take a picture of your skeleton by having a camera that sends out these waves and then only reads these waves, only picks up these waves. So it's not going to pick up the visible light or ultraviolet light waves. It's only going to be able to capture images from the X-rays so that you can see these bones. That's a great thing. That means if you get an injury, you don't have to go to a doctor and have them cut you open to see if there's a break. This is an easy way to check that out so that we can be treated and healed as quickly and efficiently as possible, but also with very little invasive techniques, so that we're not having to needlessly open someone up. But X-rays can be dangerous. These, like I said, these have a lot of energy, and if you've had a lot of X-rays, it has the potential to cause all sorts of problems, including cancer and things like that. And this is why if you ever go to get X-rays done, which getting X-rays done here and there is not a problem, but if you ever go to get X-rays done, they'll give you like an apron that's like a big heavy apron with metal inside of it that prevents X-rays from going somewhere in your body they're not supposed to. So it decreases the likelihood of X-rays getting to your internal organs like your heart and lungs and liver and kidneys and things like that. The last wave we need to talk about are called gamma rays, and gamma rays are waves that have the most energy of all electromagnetic waves. They have incredibly high frequencies and really, really short wavelengths, and they have so much energy that they will easily destroy cells. We use them though because of that, because they can destroy cancer cells. So if you had, unfortunately, if you had like a cancerous spot on your skin, doctors may use what they call a gamma knife, which is really just a beam of gamma rays targeted at those cancer cells to destroy those cancer cells so that they can't continue to reproduce and create more cancer cells. So while they're potentially really dangerous because they have so much energy, we can harness that energy in a way that's appropriate, and we can treat certain type of cancers with it. So those are all the waves of the electromagnetic spectrum. So again, the electromagnetic spectrum is the range of all of the waves in the that are electromagnetic, and it's typically arranged from lowest frequency, longest wavelength, and least energy, radio waves, up to gamma rays that have the highest frequency with the shortest wavelength and the most energy. So it's arranged as radio, then micro, then infrared waves. Then in the middle are the waves that we can see, our visible light, and then we have three more after that, ultraviolet, X-ray, and gamma. So there's 7 different classifications of waves in the electromagnetic spectrum. 3 that are energies less than what we can see, and then 3 more that are energies above. So again, that's radio from the lowest energy level up to gamma, which have the most energy. And our visible light spectrum ends up right in the middle, with infrared or below red being frequencies just below what we can see, and ultraviolet or above violet or greater than violet are frequencies just above the color violet that we can see. So hopefully everything works out for you there and that all makes sense. If you have any questions, stop in and see me or shoot me an email. Have a good one, guys.